Josh.
Is it playing
Okay,
yet?
it's playing now.
Oh.
Kaylin,
Did she hear that?
I don't know.
can she hear this? Kaylin, you get back to school now.
Whatever.
What?
All right. Inverse functions. We are like 2 seconds away from the end of the chapter. 1.5 is inverses. Inverses are functions that undo one another. So, inverse undoes the original. Okay, so for example, like y equals x squared. Do you know what undoes y equals x squared? Yeah, y equals the square root of x. Okay, so if I combine those together, they undo one another, okay? Really, technically, it's plus and minus square root of x, but we won't get into the technical stuff yet. But it's a function that undoes one another. It brings it back to the beginning, the way it was before, okay? So an inverse function is denoted, it looks like f to the negative 1 power, but it's not. It's not negative 1 power, it just looks like that. F inverse is f to the negative 1, is formed by interchanging the first and second coordinates of a set of ordered pairs, okay? So, when I'm first introducing this to like my algebra students, I will say like x, let's do like 2, comma 3, and 1, comma negative 4, and 5, comma negative 7, let's say that, okay? If this is the set of f, if those are the f coordinates, the f inverse would be 3, comma 2, and negative 4, comma 1, and negative 7, comma 5, because you are just exchanging the x and y coordinates, right? Okay, so that would be those two sets. That's what they would look like if you would exchange x and y. Okay, now, when you're given functions instead of set like ordered pairs, like such as finding the inverse of 4 to the x power, there are 4 steps. Do you remember doing this in 4 steps?
This is so, like, it's there.
It's so there, right? Okay, so the first of the 4 steps, step number 1, you change f of x
To y.
to y. Whoop.
And then change y to...
Change f of x to y. Number 2,
And then switch x and y.
switch x and y. Switch x and y. They go in for one another, right? What's step number 3?
Solve for something.
Solve for y. And then step number 4, y becomes f inverse of x now. Okay, f inverse of x. So we'll do this one really easy. Some people, and you guys will definitely do this, but some people do step 1 and step 2 at the same time, right? Can you switch x and y and change it to y at the same time? Like f of x is my y, so I'm gonna change this guy to a y, and then I'm gonna switch x and y. So x is equal to 4 times y. That's like step 1 and 2 at the same time. Okay. Then step number 3, I'm solving for y. So how do I get y by itself? Divide by 4. Okay, so a lot of people call that x over 4. I'm going to write 1/4 x rather than x over 4 equals y. And then 4, step number 4 is y becomes f inverse. And I'm going to switch it around. Can I switch the equation left to right also at the same time? Can I do that? So the inverse of 4x would be 1/4 x. Because those two things would undo one another, right? Multiplying by 4 is the inverse of multiplying by 1/4. Yeah? Okay, it's kind of like the reciprocal. Okay? All right. And then it says verify that both f composed of f inverse and f inverse composed of f are equal to the identity function. Circle identity function because that's important. Okay? So first thing we're going to do is this. We're going to take the inverse function and we're going to stick it inside the original. So we're going to take the inverse and shove it in the original. This is a composite, right? F composed of f inverse. So the inverse function was 1/4 x. We're going to shove it inside of the f function, okay? So my f function was 4x to start with, but I'm going to stick the 1/4 x, the inverse function, inside of that, right? That's what f composed of f inverse looks like. I stick the inverse function inside of the original function. Okay, what happens to this? The 4 and the 1/4 kind of go away, right? So this is equal to x. This is the identity function. Identity function. Identity function, that's what he is, okay? Now, same thing, but the reverse. I'm going to stick the original inside of the inverse. So 1/4 x becomes 1/4 times 4x, right? I stick the inverse inside of the original. Or the original inside of the inverse, sorry. What happens there? Same thing, right? X, okay? Now, if I did this correctly, I will end up with x as both of the answers, right? If not, then you won't end up with x as one of the answers, or both of the answers, right? So, we know we did this right because he is the identity function. Now, here is the deal. What? Both of them need to be x's in order for this to work. Usually, if one of them is not x, the other one's not going to be x,
So
right?
it like has to be x.
It can't be like 4 and 4. It can't be the same number. It has to be x, okay? And the reason why it has to be x is that when you have, I'm going to skip all the way down to below here, okay? When you have two functions, so skip all the way to the bottom, and then I'll go back up to the top. So the reason why it has to be x is because when you have two functions that are inverses of each other, I don't know if you guys can see this x and y graph right here. Like this, I don't know, he's right here like this. That's your coordinate plane, okay? So we have this first function here, and then we have the other function. Those two are inverses of each other. You will notice that when you graph two functions that are inverses of each other, they will always, always, always be reflected across this magical dotted line. And that magical dotted line is y equals x, right? That magical dotted line that they are reflected across is y equals x. Every single function that is an inverse, if you graph them, they will be reflected across that line. Does that make sense? Always. Yes, yes. They're reflected across that line. So that is the reason why when you compose one inside of the other, it turns out to be x. Does that make sense? It turns out to be x here and x here. If that does not take place, they are not true inverses of each other. Okay? Good? Yes? Okay, so they want us to do that. They want us to say which of these functions is the true inverse of this guy, okay? Now, we can do this a couple different ways. We can compose them and see if they work out, or we can just find the inverse of this guy and see which one he matches to. Which one would you like to do? Find the inverse? Let's just find the inverse of him, okay? So, we're going to do those 4 steps to this guy. All right, so the first step is switch f of x to y. We're going through those 4 steps. Switch f of x to y, and then we're going to change x and y. So x equals 5 over y minus 2. Oh, boy. And then what? We want to solve for y. Okay, so how do I solve for y? How do I get y by itself? Okay, so I'm going to times the y minus 2 to the other side, right? Times y minus 2. Okay, don't distribute the x through, though. What? Divide by x, yeah, let's get the x gone now. So y minus 2 is just hanging out over there. And we're going to divide the x over, so that will look like 5 divided by x, right? And then what?
Times, no, okay.
Plus 2, y equals 5 over x plus 2, or if you change it back to f inverse of x equals 5 over x plus 2, okay? So which one does he match up with? H of x. Those two are inverses of each other. Okay? And you will find that when you stick one inside of the other and vice versa, they should come out to be x on both when you simplify, yeah?
Why can't you just take it times the 5th and add 2?
Maybe?
Take it times 1 over 5, right? And then 5 and add 2. And it's not the same thing. So why
Why can you not do that?
So if you take it times the 5th, right? You have x over 5 on one side. And
But then the x will still be in the bottom over here. Does that make sense? We take times 1/5, that gets rid of
Okay.
5, but the x will be in the bottom. Yeah. Good question. Okay, so there's that. So they are reflections of each other across the line y equals x, yeah? Okay, let's go to the back side. Just a little bit left. Now, people get this confused all the time. Are you ready? This is not a hard concept, but you're like, what is going on? Okay. You do, to figure out if something is a function or not, you do something called the vertical line test, right? We've talked about that before. Woo! The vertical line test, okay? So here is the function. I'm just making this up. Let's say here is my function, right? This is what my function looks like. He is a parabola, okay? So if I want to know if this is a function, is this a function? I would do the vertical line test to it, right? Does he pass the vertical line test?
Yes.
Yes. He is a function, okay? But now instead, if instead I say, wait a second, is the inverse of this thing over there a function? I want to know if this guy, this graph that I just made, if his inverse is a function, what I can do instead is I can do the horizontal line test to that thing, right? To determine if his inverse is a function, right? So if I do the horizontal line test, does he pass? No. So no, his inverse is not a function. Does that make sense? Okay. Now, so Josh says, okay, that's x to the second power. He says, wait a second, the square root of x, the graph of the square root of x should be a function, right? Okay. But technically, y equals x squared, the inverse of y equals x squared is not just the square root of x, it's plus and minus square root of x. So he looks like not only that, but this as well. So there he does not pass. Does that make sense? Okay, so because you incorporate the plus and minus, then he does not pass. Good? Okay, so to find whether something's inverse is a function, you do the horizontal line test. To figure out if he is a function himself, you do the vertical line test. Make sense? Okay, I have a lot of people that are like, wait a second, so what do you do? Okay, yeah, okay, all right. Okay, so use the horizontal line test to determine whether each function has an inverse function, okay? So let's talk about what this guy looks like, all right? X to the third power minus 1. No. You know what x to the third power minus 1 looks like?
It's like that.
No.
But
no.
down 1, right? X to the third power is this function right here, but he's down at 1. He's at negative 1 right here, right? Okay? So is this guy himself a function?
Yes.
Vertical line test says yes.
Yes.
Is his inverse a function?
No.
Yes. Yes.
So the original.
Gotcha, there, you thought I was
The
right.
original, yes function.
Wait, no.
Okay?
No.
The original is a function. The original is a function, right? Okay, so
I'll fight
now
you.
let's talk about the inverse. Shh. The inverse. Is the inverse a function?
No. No. It can't be.
If you do
It has
horizontal
three things.
lines, does he pass?
It has 3 zeros. It can't be.
What?
It has 3 zeros. It's x cubed. It can't be.
Okay, but some of those zeros have multiplicity of 3.
Oh, idiots. It's
Wait,
the horizontal line test, Josh. Passes, okay?
Shut up, Dave.
Okay, so I just
Yes,
hate
yes, yes, yes. Okay, so think about it this way. So Allison says, what's the inverse of x to the third power?
No, negative.
But the cubic root.
The cubic root. This guy's inverse would be like the cubic root of x
Plus 1.
plus 1 on, let's see, oh no, it'd be minus 1 on the inside. No, it'd be plus 1. Plus 1 on the inside.
Plus 1 on the outside.
Plus 1 on the inside. Because it's going to move him left 1. He's going to look like this over here. He's going to look like this. Right? Okay, plus 1 on the inside means left 1. So he's moving to the left 1. Now, we know that that's true because he's across the dotted line. So is that one pass?
Yes.
Yes, he does pass.
Wait.
X to the third power is a function. So yes, he's a
Josh,
function.
shut up.
Change that, right?
Josh, shut up.
What?
So, like, if you change an x
Josh,
squared power,
shut
it
up.
will
You
always
tell
be
me
a
to do
function.
one.
What?
Like an x squared will always be a function. So not every x cubed will be a function because you have 3 zeros.
Because sometimes he will loop. Yes, so you have to, not every, yes, I get what you're saying there, yes. So he's saying not every x to the third power
Oh my
function
God.
is going to be legit, right? Because some x to the third power, I'll write it here so Kaylin can see this. Only x to the third power by himself has a function that's an inverse, but if he, for instance, does that, because some x to the third powers do go up and then back down again, then this one will not have a function, right?
Yes, because you have to do the horizontal line test job.
Yes,
Just do
yes,
the test,
yes,
and it's yes or no.
But I understand what you're saying. Yes, yes, you're saying that not only the x to the third power. I agree with you. You're doing good. You're doing good. Yes.
You
Okay.
got chicken bones.
All right. Now this one, we already know the answer to part B. We already know the answer to part B. What does he look like?
So I'm some blob.
Shh. All right. What does part B look like? A parabola and down one. He looks like this. Okay.
No, sir.
So is the original function?
Is it though?
Yes, he's a function. The original is yes, a function, but the inverse. Using the horizontal line test, we can see the inverse is not a function. No function. Okay, no function. Oh, I don't know why I did that. No function. There we go. Okay, good. Are we clear? Yes, clear as mud? Okay. All right, so it says guidelines for finding an inverse function. You don't necessarily have to go through this checklist every time, but let's see what their suggestions are. So use the horizontal line test to determine whether he does have an inverse or not, because some of them won't even have an inverse as a function. Okay? In the equation, replace f of x by y. This is step number 1. Step 1. Step 2, interchange the x and y. Step 3, replace. Oh, and solve for y. This is steps 2 and 3 at the same time. And then step number 4, they have as number 4. Okay, so my 4 steps, they have them as 2, 3, and 4. Do you see that? And then number 5, verify that that is truly the inverse by plugging them in.
Actually, look we leave it?
Volleyball players are leaving. Volleyball players are leaving. Okay, so we only have 2 left. And Allison. Allison's got to go too.
Good luck, Madison.
So, good luck, volleyball players.
And Jasmine.
Is it just there, Central?
I know, right?
It is? Okay.
You're all get that W. Right now.
It's Annie. It's Annie. That's from like 7th grade. No. One day I'm gonna say it for the last time. And I'm gonna depressing. Anywhere else.
Okay. So we want to find the inverse of these 2 functions. Last thing, very bottom, I just wrote them out again so that we have room to work below. Okay. So we want to first and foremost switch f of x to y, and then step number 2 says switch x and y. So
Good luck, guys.
goodbye.
Okay.
Okay, we're doing that. Okay. Switch x and y. There they are. And then what? Solve for y. That's step number 3. So let's do what?
Multiply 2.
Multiply 2 times 2. Okay. So 2x equals 5 minus 3y. Then what?
Divide by.
Nope.
Wait.
Minus 5. Minus 5. So 2x minus 5 equals
Then you divide by 3.
negative 3y. Divide by negative 3. Divide by negative 3. Y equals 2x minus 5 over negative 3. If you want to separate those out and write it as negative 2/3 x plus 5/3, that's fine. You sure can. And change the y to f of x. So f inverse of x equals 2x minus 5 over negative 3. And that will work also like that. That is the inverse. Okay? That is the inverse function. Okay, last one. This is step number 4, by the way. Okay. Last one, number 2. Step number 1, switch f of x to y. Step number 2, switch x and y. X equals the cubic root of y plus 1. Okay? And then what?
Solve for y.
Solve for y. So? What do I do now?
Cube it.
Cube it.
Then minus the 1.
Cube it, and that makes it go
Add
away.
the 2.
So,
Carry the 4.
not Cade. So, x cubed equals y plus 1, because that just falls out. And then subtract 1. X cubed minus 1 equals y.
Inverse
Or
f of x equals x cubed minus 1.
there he is. There he is. Okay? There she be in all her glory. There you go. That's it. That's all.
You knock it off of the